Alright, so now we're ready to start with the ratios worksheet. So at the top, there's just a reference to the definition, right, from the text that you should have read. So it's saying a ratio is a comparison of the relative size of two or more quantities. If the ratio of quantity A to quantity B is 2 to 5, or 2:5, then for every 2 units of quantity A, there are 5 units of quantity B, right? So something to recall, is that when we have a ratio and we're comparing two things, like for example, maybe we're comparing male to female ratio, right? So maybe there are um, two males and let's do 12 females in the QR class at Marion Tech, right? So what this means is that if you imagine here's our classroom, right? I have two males, and I'll grab a different color, and we have 12 females, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So there's 12 total. And actually, let me take this M away and let's put it right underneath, so that way I can emphasize something, right? So what I want to emphasize is what it means to have a ratio, right? So we could display this ratio as 2 to 12, right? Understanding that this is males to females, right? So order matters in the sense that we need to specify, in what we're comparing and in what order, right? So I could also say that we have a 12 to 2 ratio for going female to male, right? So we can show ratios a couple of different ways. We can show it with this notation with a colon. I can also show it as a fraction, right? Males to female, or I can use the word 2, right? So those are different ways we can display ratios, right? Another thing to recall is that we can simplify ratios, right? So instead of writing 2/12, right, I can divide top and bottom by 2, right, and make this be 1/6, right? So what this means is for every one male, right, there is 6 females, right, in this particular class. Right, and if you look at our diagram, it's easy to see this, right? So here's one group where I have one male and 6 females, and then here's another group where I have one male and 6 females. Right, so we can so often enough, it's easiest to think about ratios in terms of a fraction. Just simplify the fraction. Right, so if we look at this table, it says, what are the two quantities being compared in the following ratios, right? So the first one is GPA, right? So when you calculate GPA, right, you take what's called quality points and divide by credits, right? So those are the two things we're comparing. It's a form of a ratio, right? So you're taking quality points and comparing it to the number of credits that you've taken, right? The next row, only one U.S. adult and 5 could calculate interest, right? So what we're comparing here are U.S. adults who could calculate interest, right? So U.S. adults who could calculate interest. See, I'm not having enough room to write in this. Let me actually make this larger. Right. Alright, so we were on row 2, right? So this would be U.S. adults who could calculate interest, right? So U.S. adults who could calculate interest. And then the second thing that we're comparing are all U.S. adults. Right. So the next row, it says 13% of U.S. adults are numerate. Right. So when we calculate percentage, right, we're calculating the people who fit in that category compared to all the people in that particular group. Right. So we would compare the U.S. adults who are numerate and compare that to all U.S. adults again. So the next we have APR equals 6%, right? So we looked at APR before, right? So if you think about this a minute, what we're comparing, right, for this ratio is we're comparing interest, right, to the balance, right? So APR is annual percentage rate, right? So if we take the yearly interest, we compare it to the balance. The next row we have speed is 7.24 miles per hour, right? So if we think about miles per hour, miles represents distance and hours represents time, right? So this units can help us remember what type of ratio this is, but this would be distance compared to time, right? In fact, you've maybe learned before that distance equals rate times time, right? So this means that rate would equal distance divided by time, right? So it's a ratio comparing distance to time. On the next row, we have half of 17-year-olds who don't know enough math to work in an auto plant. Right, so the thing one that we're comparing are the 17-year-olds who don't know math. Compared to all 17-year-olds. Right, the next row says math SAT scores for elementary education majors compared to the national average is 483 versus 515. Right, so what we'd be comparing are math SAT scores for elementary ed majors and comparing that to math SAT scores for all students, right? So math SAT scores for all students, right? So we have the national average. The next row is you can borrow $300 and pay $350 at the end of the month, right? So in this sentence, we'd be comparing the principal to the new balance, right? And then lastly, 52% of freshmen say their emotional health is above average. So what we would be comparing are the freshmen that are above average compared to all freshmen. Alright, so when we have ratio tables, one thing that, when we talk about ratios, one thing that can be helpful to organize these quantitative relationships are to make ratio tables, right? So here's an example of a ratio table, right? So some things to point out, when we go from one row to the next, right? One thing we can think about is what do we multiply by, right, to go from one row to the next, or maybe one column to the next, right? Also, notice how this value here is a 1, right? That means that we have scaled this quantity to 1, right? Or if we look here in the in the private Fourier column where it says 100, right? We would say that we have scaled this quantity to 100, right? And we're going to learn more specifically why it can be useful to scale these quantities. All right. So by making some of these charts bigger, I messed this up. So give me a moment to fix this. I'm gonna pause the video. All right. So looking here at number 1 on the next page, it says determine the ratio of private Fourier to public Fourier in-state with the second quantity scaled to 1 using the fundamental solution technique to compute ratios. Right? Alright, so the first step, we want to set up the proportion. So one thing that I like to do when I'm setting up a proportion is write down what I'm comparing, right? So I'm comparing private Fourier, so I'll just write private Fourier compared to public Fourier. In the public Fourier, we're comparing to end state, right? So if we look above, our variables are private Fourier, public Fourier end state, and public 2-year, right? Alright, so I'll set up my proportion. So we're going to compare things. So anything in the top will be related to private Fourier, and everything in the bottom will be related to public Fourier. Right? So if we look at the table, right? So the private Fourier, we have 30,094, right? So 30,094. And then if we look at public Fourier, we had 8,893. And then we're asked to scale the second quantity to 1, right? So the second quantity is 4. So when we say scale that specific variable or this quantity to a specific variable, what we're meaning are just put 1 in its place, right? We call it scaling, but that's essentially what it means, right? Just put 1 there, and then this would be x, and like find x, right? So then now to solve this, right, we can cross multiply. Right, so if we make like a big X, right, we can cross multiply. So in other words, what I'm doing is essentially multiplying this left side by this denominator, both sides by that, and then multiplying both sides by the right hand side denominator, right? So if we have A over B equals C over D, right, then this also means that A times D equals C times B, right? So we cross multiply, right? I multiply this way, and then I multiply, and I set it equal to and multiply this way, right? That's cross multiplication, right? So cross multiplication, right? So I won't spend time proving that to you, but it's important to understand how that works and why it works, right? I'm sure you've done this a lot. So when I cross multiply, right, what I would end up getting, right, is 30,094 times 1 equals 8,893x. Right? So then if I, so 30,094 times 1 is just 30,094. Right? So this would give me, so I'll write it up here. So this would be 30,094 equals 8,893x. So divide both sides by this 8,893, and we're left with just x, right? So this comes out to be, I believe, 3.4. Right, so we can double check this really quick. So if I take 8,893 divide by, or excuse me, so let me put this in here. So we need to take 30,094 divided by 8,893, right? So if I hit enter, right, so if we round this to the nearest tenth, we get 3.4, right? So I'm going to put approximation symbol here, right? So for approximation, I can put a dot above the equal sign. That means approximation, or you can use a wavy equal sign, right? Either way. So we could do this also, right? So it just indicates that we rounded, right? All right. So then, looking at number 2, it says fill in the values of all the boxes in the ratio table. For the greatest accuracy, you should always try to use the original statistics in the second row of the table, right? So anytime that we're filling in the box, we should always be using these values, right, in the first table, because these are exact values. If we don't use these values and we use values anywhere else, that we're most likely going to have a rounding error, right? So all these empty boxes, typically we might show a rounded approximated answer in those boxes. We might write that in. So if I use an approximated answer to get another answer, then we have what's called a rounding error, right? We're like approximating twice. So we're going to be off some, right? So that's the caution that we're given, right? So if I want to find, for example, what goes, so actually in the first one we already found what goes here, right? So number 1, right, we found what goes in this box, right? That's what we were estimating. Comparing private Fourier to public Fourier and scale the second quantity to 1, we got 3.4, right? So 3.4 goes here, right? So if I want to find this box, right, one thing I could do is I could compare public Fourier in state to public 2-year, right? So we could come over here and we can compare public Fourier to public 2-year, right, as my ratio. So I can make a proportion. I can do 8,893 over 1, right? And then or excuse me, no, the 1, right, should be with the public Fourier, right? Because everything in this column is public Fourier. And notice in my chart, I put public Fourier at the top, right? So that means everything on the top should be public Fourier. So the 1 should go here, right? So it's important to note that. And then for public 2 years on the bottom, so this amount we have for public 2-year is 3,264. And I don't know what goes here, right? So I'll put X. Right? So then we could solve for X, right, by cross multiplying. So to get X, I'll end up taking 8,893 and dividing by 3,264. Right? Or, wait, have that backwards. Right? So if we cross multiply, we would get 8,893x equals 3,264, right? So now I would divide both sides by 8,893, and so I would take. So let me grab my calculator, right? So we would take 3,264 divided by 8,893, and end up getting about 0.37, right? So this would be approximately 0.37, right? So I can fill that here in the table, right? So don't forget, if you know the shortcut for doing proportions, that's okay. If you notice, what you'll do is you always find the diagonal, right, that has two numbers in it. Multiply those two together, right? So that would be this number, and then you're always going to divide by whatever's left, right? Whatever number's left. So it's the number across from your unknown, right? So that's a pattern with proportions, right? So you've probably been doing proportions a long time, right? Probably at least since middle school. All right. So let me erase this, and we'll move on to the next row. Right. All right. So another thing that you can notice is that we can compare things like row 1 to row 2, right? For example, so if I do this, right? So if I go 3.4 to 100 equals, right? So this is for private Fourier. And compare this to public 2-year, right? Then I would have 0.37 over x, right? So this would be a ratio to try to find this value, right? But remember, this is what I was talking about. We don't want to do it quite like this, because we want to be cautious of the rounding error. So remember, this value, this 3.4 was rounded. Also, the 0.37 was rounded, right, if you recall back. So that means this value, this x, is going to have a drastic rounding error, right? Although this proportion isn't set up wrong, we just have to keep that in mind, right? So we want to avoid rounding error, right? So to be able to do this better, so let me erase this. Oops. So in order to do this better, we could compare this row, right, to this row. So this was row, right? So if we let this be row 1, right, this first row, so we let this be row 1, row 2, so this will be row 3, and this will be row 4, right? So I think I misspoke or misreferenced rows, right? So what I was doing before is I was comparing row 3 to row 4, right? So I believe I wrote this wrong, right? So you might want to correct that in your notes, right? I apologize for that. So we were comparing row 3 to row 4. Right? So what the nice thing about a proportion table is or ratio table, is that we don't have to necessarily write proportions each time. We can just kind of visualize it in our head on what would go where, right? So kind of the rules are, um, is that you want to compare like row to row, and you have to be comparing things in the same columns, right? So for example, if I want to fill in um, this value, right? Let's say, right? So in the light blue, then I would want to um, take. So if I want to fill this in, I would want to take this value on the left 100, right? And I could compare it to another value in the same column, right? So for example, I could take this 30,000 value, right? So take 30,094, and I could compare it to 100, right? But in order for this to make sense, I would if I'm trying to find this value, right? So let me call this, I don't know, z, right? So I would put z here, right? And notice it's in the same row, so these are matching up, right? These are related because they're in the same row. And then also something else important is these two things are related because they're in the same column. So whenever you're setting up a proportion, this is one thing I recommend to students, is doing like what I call like the L check, right? So notice how this makes like an L shape, right? So if things are related, if they make sense vertically and also horizontally, make like this L, then your proportion would be set up correctly, right? So then what would be going here, right? So the L check's important, right? But the things have to make sense horizontally this way also, right? And also vertically this way, right? It has to all make sense. But the L check, I think, helps keep us in the right order. So 30,094, right, is in row 2. So I need to pick the value that's in the same column as Z, but in this row also, right? So that would be the 8,893, right? So this would be my proportion. So we have 30,094 over 100 equals 8,893 all over Z, right? So in order to find Z, we would need to take 100 times 8,893, right? That's a 3. Right, so we multiply the two values that have numbers, right? The diagonal that has numbers, and then you can simply just divide by the number that's left, right? So the 30,094. So if we grab my calculator, so if I take 100, oops. So if I take 100 times 8,893, right, and then divide that by 30,094, then I'm getting 29.55, right? So that rounds to be about 29.6, right? So we could fill that value in, 29.6, right? So we could keep doing this, right, to fill in these two values, and also this third one. So in order to find this third one, the proportion that I would set up would be 30,094 over 100, right? So these are in the same column. So I'm trying to figure out what's in this red circle, right? So we could let that be, n, right? Any variable you want. And then what's in that column, but also in the same row as the 30,000 number, would be this 3,264 value, right? So now if I cross multiply and divide, right, I can figure out this value, right? So we can take 100 times the 3,264, divide that by the 30,094, and we get roughly 10.8 we'll say 10.85. Right. So then to find these two missing values, right, we would do something similar. So I'll let you try that on your own. So I would pause this video and try to do this on your own, and then I'll give you the solution that I got. Alright, so if you round both values to the nearest tenth, I get 9.2 and 2.7. Right? So then number 3 says, what number do you multiply to go from the values in the third row to the fourth row, from the third column to the first column? Note that there will be some discrepancy with the values obtaining by doing this and those in the table due to rounding. Right? So some people might have some different values just depending on how you round it, and if you have rounding error from not using the exact values, right, which is discouraged, right? So what I would say is we would multiply, oops, so let me make this text larger for you. Right? So I could say multiply by, let's see, so we're going from third row to the fourth row, right? So I have those labeled above. So to go, so what I'm zoning in on, so let me put this in this pink color, is these two values, right? This is what I'm zoning in on. So we have 1 to 29.6. So how do I get from 1 to 29.6? I multiplied by 29.6, right? So in other words, if I take 3.4 and multiply by 29.6, I should get 100 or thereabout, right? Because again, this is rounded, the 29.6 is rounded, so it is not going to be exact, but overall, that's what we're doing, right? So we could say multiply by 29.6 to go from third row to the fourth row, right? And then next, I would say multiply, 9.2 to go from the third column to the first column, right? So notice if I look at the third column, to get to the first, so I'm zoning in on this 1 and 9.2, right? So to go from here to here, I multiply by 9.2, which seems about right? If I go from 10.85 and multiply by 9.2, I'll get roughly about 100, right, and so forth, right? So then the next question is looking at this data table and asking some questions about it, right? So I'd really take a moment to really read through the table and make sense of it, right? Start by the title. So it says number of courses taken during freshman and sophomore year, where we have a standard cohort of 1,000 students, right? So this is division and department, right? So down here we have humanities, and it lists different department courses, and then it's broken out into the following variables. We have whites, Asians, Latinos, blacks, right? And also one important thing to notice is look at the source from where this information is. So actually on Canvas, I provided you with this link, and so I would urge you to go to this and click on this top one, page 24, and you can read over this a little bit, right? So this is part of the book on Google Books, so just a small portion of the book that you can sample, but if you read through this, you can get kind of an understanding and be able to answer the next question, right? So again, I would pause that and read through this and try to answer this on your own. We would mimic this in the classroom if you were taking this course on campus. Oops. Let me go back to the notes, right? Right, so I'd give you some time for you and maybe a buddy to read over this and see what you think, right? But this should be, you should get an answer that has a similar meaning to this. So I would say something to this effect. So we're asking what does the number 541 mean in the first column, right? So specifically, we're looking at this value. What does it mean, right? Tell me what this number means. And it's not as maybe it's not as simple as one would think, right? So you got to really think about what that number means. So this is what it means. Right? So if you took all of the first year white students in the country and tracked them for 2 years, counting all of the art and art history courses that they take over the 2 years, and then take the ratio of the total number of such courses to the total number of these students, scaling the second quantity to 1,000, you get the ratio 541 compared to 1,000. So it is 541 art and art history courses taken over the first 2 years of college by a standardized cohort of 1,000 white students in whatever year that they did this. Right? Oops, I have a typo here. Let me fix that. And let me make this so you can read it better. Right? So this is what, this is like a really good answer for describing what this number means, right? So we're being very, very specific, right? So again, this class takes time to dissect things, right? This class is going to use maybe parts of your brain or critical thinking skills that you're not accustomed of doing, right? So we have to really think about this and explain it in the best way and really understand what this number means, right? So the key thing is how it says standardized cohort of 1,000 students, right? So what we did is took all the data and scored everything to 1,000 then, right, to make it a standard cohort of 1,000, right? So that was key. And then if you read in the text, right, one thing that you would learn is that this data is recorded over the first 2 years, right, tracked for the first 2 years of college, right, and see where they fit into this. So now in number 5, it says compute the ratio of English to art classes for each column and scale the ratio so the second quantity is 1. Right, so we want to compare English to art, right, for each column. So we want to do it for whites, Asians, Latinos, and blacks, right? So we want to go English, which is here, right? So this will be like the first one. So here's the yellow, then I'll finish this out. Right, so in other words, we want to compare the yellow to the green. Right, so we want to focus in on those values. Right? Alright, so I'm actually going to do this problem off to the side right here, right? So that way I can reference the table. So for the whites, so I would do, so we do English to art. So I would do 1,567 compared to, and I'll just write this off to the side, English to art, right, just to help me keep track. So 1,567 to 541, and we were asked to scale the second quantity to 1, right, so we're just filling in a 1 here, right? So to get this, I would take 1,567 and divide by 541, right, to get this top value. So if I do that, alright, so if I take 1,567, 1,567 divided by 541, I get roughly 2.9, right? So we'll round this to 2.9. Right? So then for the next category we have Asians. Right, so that proportion would look like this, right? So remember, English to art. So we would do 1,414 compared to 459 equals, and then you would have, so scale this to 1, and then we would try to find this value. Right? So if we take 1,414 divided by 459, get roughly 3.08. Right? So next we would do Latinos and then blacks. Right? So for Latinos, right, we would do 1,536 over the 505 equals blank over 1, right? We're trying to solve for x, right, for this unknown. So I cross multiply. So remember, the shortcut is we multiply the 2 with numbers across, divide by the 1 that's across from the variable, right? So I'd end up just taking 1,536 and dividing it by 505. Right, so we get 3.04. Right? And then lastly, for blacks, we would take 1,589 all over 291 equals, I'll use y over 1. Right? So I would take 1,589 divided by 291, and I get roughly 5.46. Right? So those are the values that you should have calculated, right? So one thing that you want to notice is the mathematics that we're doing right now is not really complicated, but we're applying it to complicated situations, right? Very applied. So being able to dissect this chart, that's the focus, the skill that we're trying to learn how to do, right? So this math should be very easy. You should know how to do that just fine. Right, so we just got a couple more problems left. So number 6 says compute the ratio of art to English for each column and scale the ratio so that the second quantity is 100. Right, so we want to kind of go in the other direction. We want to go from art to English, right? Where before we went from English to art, right? Yeah, English to art. So at this time we want to go from art to English. And we want to scale this second quantity to 100, right? So my general setup will be this, right? So let me do it for first couple with you. So for whites, we would do 541 compared to 1,567, right? English classes, and then we want to solve for this unknown, right? So in order to solve for that unknown, I'm going to take 541 times 100, right? The diagonal with the two numbers, and then divide by when we have just the one number left. So 1,567, and I get roughly 34.5, right? So this would be 34.5 for whites, right? So we could do this for every for Asians, Latinos, and blacks. So I'll just write down what quantity or what ratio you should get, right? So for Asians, you should up getting 459 over 1,414, and then this would be over 100, right? So here we would take 459 times 100 divided by 1,414, and we get roughly 32.5. Right, so this would be 32.5. So then we could do this for Latinos. Right, for Latinos we would have 505 compared to 1,536, right, from the table. And then this would be over 100, trying to solve for this value. So to get that, we would take, 565, or no, that's 505, right? Let me fix this here. So this is 505, right? So if I take 505 times 100, and then divide that by 1,536, I get about 32.9, right? So this would be 32.9. Then lastly, we need to do this for blacks, right? So for blacks, we would take 291 compared to 1,589 equals, and then scaling it to 100. So then to solve for this quantity, right, we would take 291 times 100 and then divide by 1,589. You get roughly 18.3. Right? So there's all of the ratios, right, for number 6. So number 7, it says, how is the ratio to whites computed? What are the two quantities involved, right? So if we look back up at the table, so let me highlight this in the this blue color. What we're talking about is how is this calculated, right? So this might not be so apparent, but if we're trying to read and understand this table, right, what we might have to do is think about the, or excuse me, yeah, think about what these columns mean, right? So this is the total, right? So what's the color? So I haven't used this like magenta color right yet. So this column is the totals, right? And this is the ratio to whites, right? So if you think about this a little bit, maybe do a little math, what you'll notice is that this is just a ratio where we're taking the total number of classes that the Asians have taken, for example, and compared to the total number of whites, and that's how we get this 0.81, right? So it looks like this value, 6,116, could be about 81% of 7,505, right? Or maybe a little more apparent if we look at the 7,405 for the Latinos. That's pretty close to 7,505, right? So notice it's 0.99, so that would be 99%, where this 1.0 would be 100%, right? So let me put this in words, right? What we're noticing. So what we could say is each total was compared to the white total of 7,505, I believe, right? And the second quantity, whites, was scaled to 1. Alright, so the number 8 is something you can do on your own. So it says create 3 ratios of your choosing and scale the second quality to a nice number, right? So and also, right, well, before we go, maybe for number 7, what might also help understand what's going on is let me do some writing off to the side, right? So let me do some erasing real quick and just maybe like one more minute. Alright, so let's look at how this value was calculated real quick. Alright. So if we take so it says ratio to whites, right? So if we take the next column, which are the Asians, right? So their total number of classes was 116, right? If we compare this to the whites, 7,505, right? Then if I compare the second quantity, which is whites, if I scale this to 1, right? Then this is the ratio that I have set up, right? So this x value should be this 0.81 value, right? That we have here, right? So if we put this in our calculator really quick, right? To simplify this, I would take 6,116 divided by 7,505, and we do get 0.81, right? If we round that. So that value makes sense, right? So that's what I'm talking about by scaling the second quantity, which is whites to 1, right? All right, so that's all I have. Thank you for your time.